All right, so let's start on lesson 4, solving equations. So I'm going to zoom in here, and you can pause the video if you want to just write this down first and then take a listen to it. It is important that you hear what I'm talking about because a lot of times these words won't make sense unless you're actually listening to what I'm saying. So an equation, first of all, an equation is a statement that the values of two expressions are equal. So an equation looks like, I'm going to move this over, it looks something like this, okay? Two statements are equal. It's saying 2x minus 3 equals 5x plus 6. That's an equation, okay? When two expressions are equal, remember an expression looks like this? This would be an expression without an equal sign. But when we put an expression and another expression together and we put an equal sign in between, that means it's an equation, okay? All right, an equal sign indicates that two expressions are the same, right? Which makes sense because an equal sign means that it's equal. It's the same. Okay, the solution to an equation is the value of the variable that makes a true statement when plugged into an equation. So for example, the solution to an equation, let's just say my answer was x equals 2. That means if I plug 2 back in to my equation, 4x, it should make the statement true. So if I plug the 2 back in, let's just say, and I solved an equation, I should get like, I don't know, 5 equals 5 at the end, something like that. Okay, so it should make the equation true. And we'll check our work and I'll show you what this whole thing means, okay? If you're unsure of like, what did you just say, Miss Earl? I'm gonna show you what that means. An equation has no solution when the statement is false. So 3 equals 2 would be a false statement. We could usually when it has no solution, you won't have any variables left in the equation. Actually, your variables will cancel out. It just depends if you solve it fully. But okay, let's just simplify it and say that when there's no solution, the variables are going to cancel and the numbers are not going to equal each other. This is not a true statement. 3 cannot equal 2, so this is when it would be no solution. Another example, 1 equals 0. That's false. 1 can never equal another number. An equation has infinite solutions when the variable cancels, but then the statement is always true, right? Here's the statement is false when it's no solution. The statement is always true when it's infinite solution. So for example, see how the variable canceled? And let's just say we had 1 equals 1. Is that true? Yes, so infinite solutions. So that just means the variables canceled out and then we're left with a true statement. It's infinite solutions. If the variables cancel out and we're left with a false statement like that, it's no solution, okay? Here's some inverse operations, negative and positive. So for example, if we had -5 and +5, those are inverse, which just means they can cancel each other out, right? If I have -5 and +5 make 0, right? If I have like 5x equals 15, what's the inverse operation? So we're saying, oh, okay, well, this is multiplication. When I cross the equal sign, remember, I always use an inverse operation. So I have to recognize what this is over here, which is multiplication, and do the opposite when I cross the equal sign. The opposite is division, right? The opposite of multiplication here is division. So I'm going to divide both sides by 5, and x would equal 3, right? So that's what I mean by inverse operations. Now this part, you might not recognize. This is, let's just say square root of 9, okay? To get rid of the square root, we square it. We square it. So the square root of 9, if I want to get rid of it, just like if I want to get rid of multiplication, I divide, right? If I want to get rid of a square root, I square. It's like the opposite. Just like, see how the 5s cancel out here when I divide? Because it's the opposite of multiplication. The square root and the square cancel out because the square root is opposite of the squared, okay? So the square root of 9 squared is just whatever's left inside. The square root of 10 squared is 10 because these cancel. The square root of 100 squared, do you see the pattern? These cancel out and it equals 100, okay? Just like 5x divided by 5, these would cancel. Now, if this doesn't make sense, that's okay, because I'm going to come back on Thursday and I'll talk about this all again, okay? We are going to review these notes, but try to understand this the best you can. Last part of the writing, if you want to pause the video and then rewatch it, or then push play when you're ready to listen to what I'm saying. So here we go. Answers to the equations look like isolating the variable. So, I'm missing something, I'm sorry. Solving an equation looks like getting the variable alone on one side of the equal sign, right? So when we're solving an equation, like how we're gonna do over here, we want to get x alone. So solving an equation means you're gonna get x on one side, and let's just say x equals 5, right? That's what you want it to look like at the end. You wanna get the variable by itself. And the answers, again, isolate the variable, getting the variable alone, getting the variable by itself, like x equals 5, right? The variable is by itself. Now, remember when I was saying, where was it? The solution is if we plug in an answer to our equation, it should be true, right? Proving a solution is correct looks like plugging the answer back into the equation to see if it's true. So that's just another way of me saying that, and I'm going to explain it when we go over our examples here. Okay, so let's do these three together. So let's look at number 1 here. If I want to get the x on one side of the equation, I need to move the x's together and then move the numbers together. So I'm going to move the 2x to this side, okay? Now, how do I get the 2x over here to collect it with this 5x? If it helps you, you can draw like a border between the two. If this confuses you, don't draw the line. I know some students tell me that confuses them. Don't do it if it confuses you, okay? So here we go. I'm gonna move the 2x to the other side. Now, don't divide and multiply here until we have to collect like terms. So you see how this is like with this because both of them have an x? Both of them have an x. This is 2x, this is 5x, right? I need to combine them. But because there's an equal sign, I need to cross it in order to combine them. I can't just collect them, the like terms right away because they're on opposite sides of this border, right? Well, how do I cross the border? I do the opposite. So I need to move the 2x over here. I know I keep saying the same thing, but I really want you to understand this and be reminded of how to do this. So this is a positive 2x, which means to get it to the other side, I'm going to subtract 2x. So 2x minus 2x is 0. That cancels out. I'm going to bring down the negative 3 equals 5x minus 2x is 3x. And then I'm going to bring down the plus 6. Now what do we do? Well, I need to move the 6 over here because I want my x's to be on one side. So, and I see that this is a number with no x and this is a number with no x, so I can collect like terms. So I'm going to minus 6 because that's a positive 6, and to cancel it out, I need to do the opposite. So 6 minus 6 is 0. Negative 3 minus 6 is negative 9. It's a bigger negative, right? Equals 3x. And then how do we get the x by itself? Well, we divide by 3. This is multiplication. So we have to divide to cross that equal sign. I'm gonna bring this line down just because I've been doing it like this whole time, like that. So negative 9 divided by 3 is negative 3. So x is negative 3. That's your final answer here. Now, what I mean by, let me zoom out here. What I mean by proving a solution is correct right here, this part right here, I can plug it back in to see if it's correct. So I would plug negative 3 in here and negative 3 in here, and I'll just do it for this first example, and then that's it. Okay, so just watch. So if I have 2x minus 3 equals 5x plus 6, and I plug in negative 3, I should get the same answer on either side. Do you see how I'm substituting negative 3 for x? So like here's 2x, 5x, right? And then I plugged in negative 3 for x, negative 3 for x, right? Everything else is staying the same. I'm just plugging in negative 3 for x. And then solve. This is 2 times negative 3. That's negative 6. I'm going to bring down the minus 3. 5 times negative 3 is negative 15. Negative 6 minus 3 is negative 9. Negative 15 plus 6 is negative 9. Is that a true statement? Yeah, negative 9 definitely equals negative 9. So does that mean x equals negative 3 works? Yes. So that's my final answer. So you see how we can actually prove it's true by plugging it in? Now, do I want you to plug it in every single time? Not for equations. There will be times where we have to plug it in because sometimes our answers won't work. But that's not true of an equation, okay? So I'm just showing you what I mean by this, okay? Okay, cool. Let's start here. So on number 2, sorry, I keep putting the colors down, and I know you guys can see that when I do it. Okay, let's draw a line. If the line confuses you, just don't draw it, okay? But I think it helps some people to see this is one of my sides, and this is another one of my sides. Remember, we need the x on one side and the number on one side, right? X on one side, number on one side. That's our goal in an equation. So I'm going to distribute here first. 2 times x is 2x. 2 times negative 3. 2 times negative 3 is negative 6. Plus 6 equals 5x. So I'm going to minus the 2x. Oh, you know what? I'm not going to do that first. I'm sorry. Let me collect like terms. Do you see how this is all one side of the equal sign? It's all to the left of the red line. That means I'm just going to combine these two, right? Remember, I only do the opposite sign if I'm moving over that equal sign or moving across that red line. So here I'm just going to say negative 6 plus 6. What's negative 6 plus 6? That's 0, right? So I'm going to say 2x plus 0. This part was just 0. Right? This part was just 0, equals 5x. Do I need the 0? No. So I'm just going to say 2x. 2x plus 0 is just 2x, right? When you add 0 to anything, it doesn't change it. So I need to collect like terms. I need to get the x's together. So I'm going to minus 2x from both sides. Pay attention here. 2x minus 2x is 0. So pay attention because I think students get this wrong a lot. 0 equals 5x minus 2x is 3x. So they're like, oh, no solution. But there is a solution because the x's didn't cancel, right? Let me show you the difference. If it was 0 equals 3, pretend that's gone. Is 0 equals 3 a true statement? No. But is 0 equals 3x? We're not done yet. We need to divide both sides by 3, right? What's 0 divided by 3? Put it in your calculator. It equals 0. 0 divided by 3 is 0. So here, x equals 0. So be careful at this stage. I think students get confused at that part. Okay. You know, the cool thing about video notes, you can watch these as many times as you want. So if this is confusing, go back and watch it again, or watch whatever part you're confused on. I'm just rewriting the equation because I took up a bunch of space above, okay? So I'm just rewriting this down here. Now, pay attention here. This is the only time we multiply first. Remember how I said we multiply and divide at the end? Okay, do you see how my x is up top here, right? I need to get the x alone. That's my goal, right? Like that. Now, if everything here is being divided by 2, what's the opposite of divided by 2? You see how everything on top is being divided? That means my first step, in order to even reach this top, I need this top part to be outside of the fraction. I don't want that over 2. I don't like that. So I need to get rid of that first. So in order to, the opposite of dividing by 2 is multiplying by 2. The opposite, remember, over here. The opposite of dividing by is multiplication. So if I want to undo division, I have to multiply by 2 to both sides. Look, that cancels out. And I just have x plus 5 on the left-hand side. And 3 times 2 is 6. How do I get the x alone? Well, I see my 5 and my 6 are like terms, but they're on opposite sides of the equal sign. So I subtract, I do the opposite. I do the inverse operation, the opposite operation, which is subtract 5 from both sides. 6 minus 5 is 1. So my answer is x equals 1. And again, we can plug this back in to x to make sure it's right, if we want to. Like if we plug this back in, what's 1 plus 5? 1 plus 5 is 6. And 6 divided by 2 is 3. So cool, that's the right answer. Do you see how I quickly plug that back into x and just to check? So I can do that. Now, again, the only time we multiply or divide first is if we have the whole thing on the top here, x plus 5, being divided by 2. Then to get rid of the divided by 2, we do the opposite of division, which is multiplication, and we multiply both sides by 2. These cancel out, and we're just left with the top, okay? So now try the practice problems, and we'll go over them together next time, but make sure you're trying the practice problems. You have to finish this by the end of today, okay? So good luck. If you have questions, email me.